Again, we are working with three different models: linear, exponential, and quadratic. And now let's practice how we can write those models based on data. The directions here say describe or decide which type of model corresponds most closely to the data and write a model. So notice we have a relation here, x and y values. So my advice to you is to plot the points. So if we plot these points here, the point 2, 10, 4, 40, $6.90, $8, $160, and $10, $250, we get a graph that looks like this. Well, we can rule out linear. We see that there's a curve to it. But do we know if this is exponential or quadratic? Is it going to keep getting closer and closer to 0 here, or does it come back up? So let me show you how we can decide whether this is quadratic or exponential. We've ruled out linear. When we talk about exponential, remember, we talk about this form right here. Y equals A times our growth factor raised to the x. So when we're doing this problem, we are raising it by the same number every single time. It's growing by the same rate every single time, or decreasing by the same rate every single time. So we're going to use the idea of ratios and rates. This is just how you do it. We're going to take and we're going to figure out the growth rate for each of these. The way we do that is to write ratios. So let's focus just on this column right here. How much did we increase from 10 to 40? Yes, we increased 30, but what was the growth rate? The way we figure that out is to write a ratio. Take 40 and divide it by 10. This year divided by this year. And what we get is 4. It increased 4 times. Now let's see if the same thing happened from this year to this year. So if I go 90 over 40, we're always dividing by the one before it, I get 2.25. Notice that it's not the same. Let's keep going. Let's take 160 and divide it by 90. I'm sorry, I'm saying a year, but it's 2 years before. When I divide 160 by 90, I get 1.78 approximately. Still at the same growth rate. 250 divided by 160, approximately equal to 1.5625. Notice that these ratios are all different. That means we're not multiplying by 4 every single time. We're not going times 4, times 4, times 4, times 4, times whatever. It's different every single time. In an exponential model, that number has to be the same. We have to be multiplying by 4 every single time. So since this number isn't the same, this is not an exponential model, it's a quadratic model. Remember, we're going to use our basic form of quadratic, y equals ax squared. So now we've got to write a model. We've decided that this is quadratic. So now, let's write a model. Okay guys, sorry about that interruption again, but I just want to, okay, so trying to remember where I was. We've decided that this is a quadratic model. We're going to use this formula. Now notice we've got to figure out what the a is, and the way we do that is to pick one of these points, and it doesn't matter which point you pick. I will pick 6 and 90. I don't know, just because I want to. So we're going to use y equals ax squared. Y is 90. We're trying to solve for what a is because we're writing a model. And x is 6. 90 equals a times 36. Divide both sides by 36. And you get a equals 90 divided by 36, which is 2.5. So, put that back into our model. Y equals 2.5 instead of a times x to the second. Now we've written a simple quadratic model for our data. If you test the points, you'll see that it works. If I plug in a 2 into this formula here, and I go 2.5 times 2 to the second, I get 10. If I go 2.5 times 4 to the second, I get 40. Now it's not going to be perfect. There might be some that are off a little bit, but you're going to see that it's close. So this model represents all this data. Again, when we're writing models, you have to first start by graphing so you can decide which model you're using, whether it's linear, exponential, or quadratic. Once you can kind of at least, if not know, narrow it down to quadratic or exponential, find ratios. 40 divided by 10, 90 divided by 40. That's telling us how much we're growing each and every time. If you're growing the same amount, that would be an exponential. If you grow different amounts, that's quadratic. Then use the simple quadratic formula, pick an x and y value, solve for your a, and plug it back into your formula. And that's how you write a model, at least a quadratic model, for a set of data.